Okay, we are still in the planar kinematics of a rigid body, and here we want to solve this particular problem. Uh, it is on the principle of impulse and momentum. Here we have 100 kg of spool as shown here, and it has a radius of gyration of 0.35 meter. Okay, 0.35 meter. A cable wrapped around the central hub of the spool, and a horizontal force having a variable magnitude of P equal to T plus 10, and the unit is in Newton. So the P is dependent on the time, if you can see. T, of course, in second. If the spool is initially at rest, okay, determine its angular velocity in 5 seconds. Assume that the spool rolls without slipping at A. Okay, it will roll to the right. Okay, to solve this particular problem, let's move on to the right-hand side here. What we have here is the free body diagram of these problems. Here we can see at point A, we have the reaction force NA and the friction of FA. And then on the top part here, we have the P, okay, which acting at certain, at 0.4 meter from the centroid G. Okay, and we also have 981 Newton, which is due to the weight of this spool. Okay, 9.81 times 100. Okay, 100. So it is 981 Newton. Okay, now on this part here, we have the our reference axis, and you can see that pointing outward is our positive y, to the right is our positive x, and omega we assume clockwise is our positive direction. Yes. Okay. Okay, moving on. Um, the general expression or the general formulation for the impulse and momentum principle is like so. Okay, like what we have here, and we have the I A omega 1 that is due to the rotation of the spool. Okay, uh, in the initial rotation. However, it is mentioned here that the spool is initially at rest. Therefore, omega 1 is equal to 0, and this part will become 0. And moving on to this part here, summation of moment that's changed with time. So MA, the moment acting at point A here, okay, moment acting at point A here, and we know that we have a force of P times P equal to T plus 10 Newton, okay, and then we know that the distance from this particular point, okay, this point up until point A here is gonna be 0.4 plus 0.4 plus 0.75. Okay, so here it is. Sorry. Okay, let me erase that one. Okay, so it is here. Okay, now this is the P. This is P, and we know that we want to determine the angular velocity in 5 seconds. So we know we start at 0 second up to 5 second as given here. Then that is equal to the mass moment of inertia of this particular spool. And here we know that we want to measure at this point A, IA. So therefore we have our, here what we have is IG plus MD square. Okay. So we use the parallel axis theorem, okay, in this case here. So IG here is the, IG is MK square. Okay, it is for the IG plus MD square. So M is 100 kg given here. K is 0.35 square plus M D is the distance from point G to point A. So it is 0.75, and the angular velocity at 5 seconds, that is the things that we want to calculate, and therefore solve the maths. And finally, you will get this, the angular velocity after in 5 seconds, it is a 1.05 radian per second, and it is clockwise. Okay, thank you.